Here is a question, not a question on the board. I'm explaining something very serious, but very, very simple. We use it in algebraic calculations, so it's very, very important we talk about it even after talking about it over time. We're talking about difference of two squares. When we say squares, the first square, the difference. When we say difference, you know it's subtraction. Difference of square x and square y. They are in square term. How do you solve this kind of question like this? This is what you are seeing on the board. These two terms, x and y, you add, close bracket, then you subtract, close bracket. Very simple. That's what you are seeing there. You add, close bracket, then you subtract. And we are going to apply it in a question like this. The first thing you do, if you don't understand the question, make sure that you are dealing with squares. If you cannot put two numbers, if they are in difference, I mean they are in subtraction form, and you cannot put them in their square form, you cannot apply difference of two squares. You can only apply it when they are in square forms. Like this one now. This one is a squared. 3 raised to power 2 is an equivalent of what? 9. Can you see that? 3 raised to power 2 is an equivalent of what? 9. In mathematics, we always play with equivalence so much. So what this one simply means is what? A plus 3, close bracket, a minus 3, courtesy of what you are seeing right there on the board. Similarly, we have something like this on the board. If you notice something, we are having numbers here, and we are actually having a number attached to a particular unknown, and that number can be raised to squares also. So the first thing is to put it in the square form, because we are dealing with what? Difference of two squares. So the square, the equivalent term of 49 is actually 7 raised to power 2, which is 49. Don't forget also, 2 raised to power 2 will give us what? So we now have 2 all in squares. This expression is exactly the same thing with what you are saying here. 2y all squared. So we can see that we've been able to put it in their square form. Their difference is just simply applying 7 plus 2y, adding and subtraction 7 minus 2y. So we are not solving any question here. It's very simple. You must understand these simple basics. The next one is also expressing it in their square form, where we say, we'll now say here is what? 6 raised to power 2. Here is 5 minus 5x all squared. All squared. You can see now, they are now in their square form. What we can now say? 6 plus 5x, close bracket, 6 minus 5x. No big deal. This is exactly what we have. Similarly, we do the same thing here. Here is 4x all squared, because you can put them in their square form. Then this one is 3 minus 3y all squared. You can put it in the square form as well. So the simple expression of this is the addition 4x plus 3y, then 4x minus 3y. For those who are writing objective exams where you are solving very fast, merely seeing something like this, where you have the addition and the subtraction, you quickly know that this is this. You don't need to waste time. And this is the thing that you learn that makes your calculation very, very fast. These are the things you need to know, especially when we are dealing with algebra, where we have to simplify. Sometimes it will involve quadratic equation, where we also involve difference of two squares. In fact, most of the algebra are seen. Algebraic fractions, they use this so often. So there's no big deal about difference of two squares, but you have to know it. If you have learned something from this video, make sure you follow this page and make sure you make your comments. Good comment that can encourage us to post more videos. See you in our next video.